Here we're asked to verify the identity sine theta plus cosine theta is equal to 2 sine squared theta minus 1 all over sine theta minus cos theta. We remember that proving a trig identity is the same as saying show that the left-hand side and the right-hand side are the same, or really showing that we can turn the right-hand side into something that looks exactly like the left-hand side, or vice versa. In general, we want to reduce things to sines and cosines, which we have, and then we want to tackle the more complicated seeming side. Not that we want to spend a lot of time worrying or fighting over what that is, but if one pops out as more complicated, it will generally be easier to simplify that than to make complicated the other side. Here, because of the ratio and of course the high powers, we generally think the right-hand side would probably be the more complicated side and therefore the one to tackle first. Our next general rule is if we have things in high powers of sines and cosines, we'd like to get them in lower powers or at least use Pythagorean identities to shuffle them around. Specifically here, we're going to tackle that sine squared theta using the Pythagorean identity. Sine squared theta plus cosine squared theta is 1, or equivalently, 1 is sine squared theta plus cosine squared theta. So we can rewrite the top to being, of the right-hand side, to being 2 sine squared theta minus sine squared theta plus cosine squared theta. And of course we have the denominator coming along for the ride. And you might ask why we do that, but of course one of our sine squared thetas will combine with the 2 sine squared theta that we had before. So now we have sine squared theta minus cosine squared theta all over sine theta minus cosine theta. Now we're going to use an algebraic identity, which is that a squared minus b squared is the same as a minus b times a plus b. This allows us to turn the numerator of our guy into sine theta minus cos theta times sine theta plus cos theta. And of course we're carrying around our denominator, which we have not changed in any way. And now we can see that anything over itself can be considered to be 1 and then hidden. So I can take this sine minus cosine theta and hide it using this sine minus cosine theta and end up with, in the end, just sine theta plus cos theta, which happily is what we were looking for. So we have verified the identity.